Now we will take a look at Gouraud shading. In Gouraud shading, using algebraic mathematics, we try to find the color of every point inside one specific polygon. If we look into this example of the car, we see that for every texture that is inside this car, suppose here, this is one surface, this is another surface, this is another surface, this is another one, this could be another one. So for every surface, we assign one polygon. It can be a triangle, a pentagon, or a hexagon. So that doesn't matter. The main part is we assign a polygon to every surface. And from there, using the vertex of each individual polygon, using proportion, we assign colors of all the points which are inside each individual polygons here. Now, here is how Gouraud shading works. If we take an example here, now, if this is the same red ball that we are trying to draw here, or assign the colors using Gouraud shading, again, we will do the first thing, which is break it down into multiple polygons. And from there, one by one, we will try to assign colors inside the individual polygons. However, in flat shading, where every single point inside one polygon had the same color, this criteria is discarded in Gouraud shading. And how so? Suppose, let's take one individual polygon here. Here, we have four vertices in this polygon. This can be named as basically C1. This is C2, this is C3, and this is C4. Now, whenever we will be given to do Gouraud shading, of every polygon that we will get, at least the colors of all the individual vertex will be given to us. And based on these vertices, we will assign colors of every points that are along these edges and also along all the scan lines inside our polygons, as in all the individual points inside our polygons here, using these four colors. So let's take an example here. Suppose I have this as C1 and the point here has the color C2. I want to assign color of this point, which I can name as CX. Now, how can I do that? Basically, in Gouraud shading, we use algebraic methods here. How so? If I want to assign the color of CX here, this is how I will do it. Since from this direction, I will basically add some color from the mixture of C1 and C2 right here, this is how it will begin. First, it will be C1 color plus this would be the color range of this height, which is C2 minus C1. And from this range, we will take the proportion of it, as in use the coordinates here, which is, if this point is C1, we can name its coordinates as X1 and Y1. We can name the coordinates of our main point CX as C0, X0, and Y0. And of this point C2, the coordinates can be X2, Y2. Now, here, what we will do is, since it's taking a diagonal direction, we will take the y values to be the dominant factor here, and hence find the color using the y coordinates. As in, at this height, the y coordinate of CX is Y0, and our starting is basically Y1. So it's Y0 minus Y1 divided by the total range, which is Y2 minus Y1. Y2 minus Y1. Using this, we will find the color of our CX here. And using the similar method, we can even find the color of this point right here, which we can name it as CR. If we look into it here, if this is CR, again, the color that will be assigned to this point on this edge will start from this C1. So we have C1 here plus the difference, which is C4 minus C1. So C4 minus C1 here. And from there, we take the proportion of our y coordinates, which is, we can name the x coordinate as XR and YR, of the y coordinate for CR. So we have here the YR minus, it starts again from Y1, hence Y1, divided by the total range, which is C4's coordinate can be written as X4 and Y4. So here we can write this as Y4 minus Y1. So doing this again, we will get the color of our C4. In this way, we can find out all of the colors of the points along the edges of my polygon. So just like this, now if I want to find the colors along these scanning lines, suppose here, here, and here, all I have to do is, suppose if this was my polygon, these are my vertices, and just now I found out the color of this point and this point, which was my CX and CR. If I suppose want to find the color of this point, I will basically use now CR and CX, for suppose this can be written as CM. This coordinate was X0 and Y0. This coordinate was XR and YR. Using the same method, I can find the color of this specific point. How so? CM can again be written as, we can assume that it starts from CR. So we have CR plus, again, we will have CX minus CR and into the proportional distance. But now, since it's a horizontal line, we will take the X coordinates here. And we can assume that the X coordinate is XM and the Y coordinate is YM of CM. So using them, we can use this again. At the top, we will have XM minus XR divided by, we have X0 minus XR. And using this, we will find the color of our point CM. So in a similar way, we will be able to find all the colors of all the points inside our polygons, and this is how Gouraud shading works. We basically take the proportionate color of our two edges here and find the colors of the intermediate points along our edges. Then using our intermediate point colors, we find the colors of the pixels which are inside our polygons. And this is how Gouraud shading works. However, even so, this one is more accurate than the flat shading model. It still fails here from one point. If I rub the diagram here to see how this shape would actually look like using Gouraud shading here, we can see that even though all of these points are rightfully colored and we still see a bit of darkness here since the illumination factor here is quite less, we still see a brighter point here. However, the spotlight or the highlighting points inside this figure are still missing, as in the colors are still very dull using the Gouraud shading. And hence, this again fails to completely resemble realism in our computer graphics, which is ultimately eliminated in the Phong shading model. Now, here we have an example of a math calculation using Gouraud shading. So, how can we do this? And what information is given to us? We have two vertices here, C1 and C2. C1's RGB components are these three values, and the coordinate of C1 is 70, 40. For C2, the RGB components are given, as in the color of C1 and C2 are given, and the coordinate of point C2 is 110, 90. The coordinate of our point CX is given, and now using Gouraud shading, we are supposed to find the color of the point CX. How can we do that? We will individually find the three components using Gouraud shading. How can we do that? Just simply following the mathematical equation. If we start with C1, red color, so it used to start with C1, right? So we will start with 0.25 plus we will have C2's R value, which is 0.67 minus 0.25 into the y coordinates. The y coordinate of CX is 65 minus of C1 is 40. So 40 divided by the y coordinate of point C2 is 90. 90 minus 40 again of C1. Now doing this, we will find the value for the R component of CX. Similarly, if we have to find for the green component, the green component starts from 0.43. With this, we will add the difference between the two green components. So 0.51 minus 0.43. With this, we will multiply again the same y coordinate proportions. So 65 minus 40 divided by 90 minus 40. Using this, we will find the green component value of CX. Again, using the blue component, it starts from 0.1, and the difference between the two blue components are 0.32 minus 0.1 into the same proportionate values here, which is 65 minus 40 divided by 90 minus 40. And again, doing this entire calculation, we will find the value of the blue component of CX. These three will together now give me the color that needs to be assigned at the point CX. Using this, we can find the colors assigned to each pixels inside our polygon here or on the edges of my polygon here using these four vertex values.